Hello everyone, welcome back to our second video of a graph of a sine and cosine function. So to start the lesson, actually this video we are going to show some examples in the decimals to graph this. But before that, I just want to quickly give you the idea of how the wave is created by using the unit circle of these angles. As you can see this graph, when we just go through the angles here, no matter it's counterclockwise or clockwise, this is actually how do we create the wave. And this wave, can be a little bit different between sine and cosine function, but it's quite similar. This is, when we change the angles, this is how do we get the wave, and also this wave can go forever because this angle can be on like 720 degree or even like just go forever. So you can see the wave is actually going forever. Trigonometric function is a quite unique function because it's represent a certain pattern here, and also just because it's special feature here, we can use this kind of function to model a lot of real life situation, just because a lot of things actually changing over time, and the time is actually can repeating over a certain time pattern. For example, over the week, over the months, over the year. So a lot of things is actually related to a sine or cosine function. That's why this type of function is quite unique and very useful in our daily lives. And also, as we mentioned before, we actually look at the sine curve and also cosine curve like this way, even though we only graph the partial of this, but you should imagine that it can go forever just because the angle can go forever for the situation. And now let's jump back to the decimals. So when you go to the decimals, you will see this. I just quickly draw sine x here to give the idea. So as you can see, this is a curve. So some student might say, and then why do you mention we can just use pi over pi, or pi over 2 or those kind of thing instead of using degree? So if I change it to the degree, hold on. For example, if you can go to the setup here. If I change to degree, you can see the graph is actually very off, right? Just because the scale of the function is actually very different. Scale between x and y is very different if we use a degree, so it really doesn't make sense we use a degree to graph. So we prefer use radian. And also, if you want to see the label on the graph instead of using these values to see clearly what it is, you can go to step here and put pi over 2, so you can see the similar graph as we saw before in the previous video. So this is y equal to sine x. What I'm going to do, I'm going to, on the same coordinates, let's use y equal to sine x as a foundation here, and let's see what happened, what is changing if I put a different value in front of a sine. Let's say this one. So as you can see, the only difference between this function, I put a 2, is like every single value of an original function times 2. So what is changing? The only changing part is actually the highest point, right? So every other thing is still the same. The pattern still keep the same. They stop, the function becomes 0 at the same point, but the maximum value and the minimum value is changing, right? This is what happened here. So we can just quickly label this one. So this one, the maximum is 2, the minimum is negative 2. This is what happened, right? Okay, now, unfortunately, I can only annotate, temporarily, but you get the idea. Now, I'm going to change again. So I'm going to this time, I'm going to times 4 sine x. So some students probably, already know what are going to happen. The maximum and the minimum value will be changing, right? So this time, just because we times 4, so before the maximum is 1, as you can see the red one here, now changing to 4. So then what happens if I times a negative number? So you can even, before we come to show you, you can even just, guess what would you see if I times negative 4. See? So if you just, compare the 4 sine x and the negative 4 sine x, you notice it's actually flipped, right? Flipped, over the x-axis. So everything before is everything positive, change it to a negative side, and everything negative side before, change it to positive. Just because we multiply a negative number, it changes. But maximum value is still 4, minimum value is still -4. So, and some other thing, for example, when the function becomes 0, it's still the same. So this is actually stay the same. Now, let's erase this one. And let's just go explore cosine x. As you can see, the cosine x we mentioned before, when x equals 0, it starts as a highest point. So you know what? Let's compare these two functions to indicate this. So for sine x, when x equal to 0, it's actually start with 0, 0 point. It's like a curve like that, if you just look at the right side. But if you look at the cosine x, when x equals 0, it start with the highest point. So the wave goes like that, like high to low to high. But for sine, it's like a middle, high, middle, low. This is like the pattern here. But both waves are very similar. So if you really explore this kind of function, you will know they can just be changing over, depends on how you translate or shift the functions. But of course, there's a lot of topics you can talk about this one. But again, as I mentioned, unfortunately, we cannot go further for that. But let's continue compare the function we have here. So just like what we mentioned, if I multiply 2 cosine x, very similar to what we observed from sine x, right? So original highest value becomes 2, original minimum value becomes -2, just because everything is multiplied by 2. This is what happened here. And also, let's move on. If I multiply an even higher number here, you will notice again, highest value change again because we multiply this. And then what happens if we multiply a negative number? Let's see, before it's 3, now I'm multiplying -3. So what's going to happen? You probably already guessed, it's flipped. Flipped over x-axis because whatever the positive becomes negative, negative becomes positive. It's like a flip over, right? So this is just what happens when you multiply a number in front of x. Of course, you can even make the number in front of x to change the function even more. But again, this is so many things we can discuss this, but I just want to give you the basic introduction of how the graph look like. So you can use this as a foundation to explore more features on your own if you're interested. This is actually a very interesting topic if you go further for that. And thank you again for checking this video with me to check how this waves are changing over the different type of function we write here. And you can always go to decimals and to explore this topic on your own. You can put the different numbers in front of function, like in front of cosine and sine, or even put a different number in front of x to to check how the graph is changing and why it is changing. And another thing I want to remind you, as we mentioned, both functions actually called periodic function. So if you are interested about this topic, you are also welcome to explore more things about this. And you will probably see some words like a period, amplitude, things like that, and midline, something like that. This is a lot of things we can introduce, but we can't just because we don't have enough time. But anyway, you can always use this term to do some research on your own, which is always a great idea. So thank you so much, everyone, to watch this video and study all these topics with me. Thank you, and take care, everyone.